Hello everyone. Hello guys, how are you? Guys, give me a quick count of the centers with number of students on the centers. Give me a quick count. Every center will count the number of students and will respond on the chat screen. Quickly. Okay. So guys, tell me, what are we discussing in the last class? What was the topic that we have discussed in the last class? Tell me the name of the topic. Shillong, guys, tell me the topic that we were discussing in the last class. Quickly. Bohr's atomic model. Okay. So, I think we were discussing about the spectral lines. Hydrogen spectrum we were discussing. Have we discussed the Lyman series, Balmer series, Paschen series, Brackett series, Pfund series, these kind of series? Have we discussed this? Tell me. Guys, tell me. Do we have discussed that? Guys, settle down fast. What was the last topic in the Bohr's model? I'm asking about the last topic of the Bohr's model. I guess so we were discussing about the spectral lines. I think Lyman's hydrogen spectrum, yeah, exactly. See, I think we were discussing about this one, the kinds of series that first was Lyman series, where N1 was 1 and N2 was 2, 3, 4, 5 and so on. Reason was UV. Next was the Balmer series, where N1 was 2, N2 was 3, 4, 5 and so on. Then Lyman, Balmer, Paschen series, where N1 was 3 and N2 was 4, 5, 6 and so on. Next was Brackett series, where N1 was 4, N2 was 5, 6, 7. Last, Pfund. P-fund series, where N1 was 5 and N2 was 6, 7, 8 and so on. I think we were discussing about this one. Tell me, yes or not? Do we have discussed this one or not? Yeah, that's cool. We have discussed about it, no? Okay, we will continue after this. Now, before that, I think we have discussed about the energy and radius of the Bohr's atomic model. So, this is the one question for you that you have to solve it. There is a structure of atom. Structure of atom, Senapati. Okay. Guys, do this question for me. That calculate radius of fourth Bohr's orbit of Li 2 plus ion. Also calculate energy in this orbit. Guys, I think we have discussed about the formula of the radius and the energy of the Bohr's atomic model. We are just revising it. So guys, do this question for me quickly. I want your answers. Do it quickly. And the student who has got the answer first will reply on the chat screen with its name. Quickly. The student who got the right answer or who has solved this question will reply on the screen with their name. Done, guys? You're taking too much time. And one more thing, guys, the atomic number of lithium is 3. I hope so. Everybody knows about it. That Z for lithium will be 3. Okay? If you don't know about the lithium, the atomic number is 3. Hydrogen, helium, and then lithium. Now solve it for me. Have you done this, guys? Okay, guys, time up. You have taken too much of time. Let's see what will be the answer. See, we know the radius of orbit in an atom is equals to 0.529 n square by z angstrom. Now 0.529 n is 4 because they are talking about the fourth orbit. Okay, we have got one answer. With your name, guys, this one will be what? 3 square upon 4 angstrom. So if we solve it, it is 0.529 into 9 by 4. So let's see what would be the answer. Okay, let me check the answer first. Okay, radius is 2.81. Are you sure it will be 2.81? Because if I solve it, this one will be 4 2s are 8, decimal 4 2s are 8, 4 5s are 20. So if I multiply it with this one, 0.53, no, answer will be something else. Radius is not 2.81. It should be 1 second, 53, 5. Answer would be 1.19, or we can say 1.2. Approximately, the answer will be 1.2 angstrom for the radius. Oh, wait. Oh, yeah. I have put the wrong values. Z should be 4. Yeah, I have put the wrong values, guys. Just 1 second. Just 1 second. Wrong values. This one should be 4 square and this one should be 3. So this one will be 0.529 into 16 by 3. I think so answer would be then yeah, answer will be 2.81. Absolutely right. Who has got the 2.81 answer? Radius will be 2.81. Absolutely right. Then energy, it will be minus of 2.18 into 10 to the power minus 18 z square by n square. So this one will be minus 2.18 into 10 to the power minus 18. Z is 3 square, n is 4 square. So this one will be 2.18 into 10 to the power minus 18 into 9 by 16. So you can solve it and you will get your answer. Okay, let's see what would be the answer. Answer should be 1.4 something. 1.4 into 10 to the power minus 18 joule. This is the energy. Okay, so guys, these are the answers. Radius will be 2.81, absolutely right, whereas the energy should be 1.4, not 1.2. Anyone else who has got this answer? Anyone else who has got these answers? Guys, have you noted this? Have you copied this? Shillong, Senapati, what's going on, guys? Have you done this? Okay. Okay, guys, this is the question. Now, let's move on to another one that we have discussed last time. Here, okay, so I got 2.14. 2.14 for which one? Senapati, answer will be 1.4 for the energy in 10 to the power minus 18. Whereas for the radius, you will get 2.81 angstroms. You can cross check your calculations. Okay. Now, let us move on to another question. Okay. Take a look. Calculate frequency of radiation during transition from fourth orbit to second orbit in He plus ion. Guys, do this one. In the previous questions, answer will be 2.81 and 1.2. Sorry, 1.4. Okay, do this question for me. Calculate the frequency of radiation during the transition from fourth orbit to second orbit in helium ion. Do it. The student will write their answer with their name. Three minutes for this question. Quickly. I hope so. You know the formula. Is there anybody who needs some help, some hint? What is? Dear, I'm not getting your question actually. Write it again. clearly? I'm not getting your question. Anybody who has done this question? Guys, do one thing for this question. First of all, use this formula. 1 by lambda is equals to 1.1 into 10 to the power 7 frequency of radiation. Dear, the radiation will definitely have some wavelength. If it has some wavelength, therefore it should have some frequency. Any radiation is like your light radiations, photon particles. They are energy particles and they always carry some frequency and the radiation. Sorry, some frequency and the wavelength. Now look at this, 1 upon n1 square minus 1 upon n2 square. This is meter inverse. Now we know the value of n1 and n2. We can put down these values and we will calculate lambda. Okay, you will calculate lambda for me, and after that you will use this relation c is equals to nu lambda. We know c is the speed of light. That's value is 3 into 10 to the power 8. You will get the lambda, value of lambda from here, and you will put in this value, and after that you will calculate the value of frequency. Now solve it and tell me the answer. Everybody will solve it and tell me the answer quickly. You have to just put this value and you have to solve the equation. 1.1 into 10 to the power 7, 1 upon 2 square minus 1 upon 4 square into helium. So you will say it is 2 square. Do it. Here you have to put atomic number as well. Solve it now. Let's see who has got the answer, who has got the first answer. Shillong, have you done this? Senapati? Guys, what are you doing? You're taking too much time to solve this question. Okay guys, let's solve it. See, this is lambda. I can multiply this 2 square inside, and after that I'll get this one. This is 1 and this is 1 by 4. Now, this is 1 by lambda actually. After that, I can write it like this, 1.1 into 10 to the power 7 into 3 by 4. After solving this, and then for lambda, I can write it like this. This one will be 4 upon 1.1, 10 to the power minus 7 will be there, into 3. Okay? Now you can solve it. This is 4 upon 3.3 into 10 to the power minus 7 meters. Okay? After that, you have to just put this value. Guys, first of all, note it down. First of all, copy it quickly. Copy it quickly. Done? After solving, you will get 1.372 into 10 to the power minus 7. This one will be your answer, 1.2 into 10 to the power minus 7. This is your lambda wavelength. Now we have to calculate the frequency. So for that, you will use this relation, C is equals to nu lambda. C is 3 into 10 to the power 8. Wavelength is 1.2 into 10 to the power minus 7. And here it is your frequency. So frequency would comes out to be 2.5 into 10 to the power 15. Which transition? In the last class, we have discussed that formula, dear. In the last class, we have discussed that formula and we have already attempted few questions. You have to check out the unit. See, I'm writing the unit meter over here. I'm writing meter. The difference is between minus 5 and the minus 7, meter and the centimeter. That's the only difference. And I was using the formula to calculate the wavelength, and after getting the wavelength, we will use it with the relation C equal to nu lambda to get the frequency. Okay? So first of all, you have to use this relation to calculate the lambda, and after that you will get the frequency. Okay? Any doubt? Any problem? Done? Guys, tell me how many of you has revised the previous topics that we have discussed in the class? Tell me. Have you revised these topics? Okay. So guys, this is the question based on the previous topics that we have discussed. Now, dear, you have to check out the formula that we have discussed in the last class. Check that formula that we discussed in the last class. In the last class that I have discussed about this constant. This is not this 1.1 actually. This is rounded off value. The value was 109677. And after putting the decimal, we will get the 5. And if we convert this into meters, it will become 7. That has been already discussed in the last class, previous classes. Guys, you have to revise the previous classes first. Otherwise, you will get confused. I'll give questions to you related to previous sections, and you won't able to solve that if you won't revise that. Okay. Now, next is drawbacks of Bohr's model. Drawbacks of Bohr's atomic model. Okay, guys. This is quite important for the examination point of view. This is asked in the CBSE examinations and in the state board examinations, that what are the drawbacks of the Bohr's atomic model. See, first of all, we have discussed about the Dalton's theory, where we were discussing about the atom, how atom is generated, how do we introduce the atom. After that, we get to know that the theory of Dalton was quite wrong, and after that, to explain the atom, the many attempts were given by the scientist, and the first attempt was given by the Thomson, and we know that that attempt was totally wrong. And after that, a quite successful attempt was given by the Rutherford, but later on we come to know that again that model was wrong. But yeah, in the Rutherford model, the discovery of nucleus would takes place. The nucleus was discovered by the time of the Rutherford. After that, again the Rutherford model was failed by the Maxwell's theory, because that model couldn't explain the Maxwell's theory. And after that, Bohr came in the role, and he ultimately explained the Rutherford model. The drawbacks of the Rutherford model was explained by the Bohr's. And after some time, when we go towards the quantum mechanics, we came to know that even Bohr's model was not appropriate. This model has many demerits that we have to discuss. So ultimately, we can say that even Bohr's model was not perfect. It has many demerits. So we'll discuss about those demerits one by one. And remember, guys, this is quite important for your examinations. This is quite important for your examinations. So the first demerit was, it was applicable to hydrogen like species only. Okay, what is the meaning of hydrogen like species? Guys, we know that hydrogen is the atom that contains only a single electron. So the Bohr's model was applicable to only those species which has got the single electron. That's why if you observed that I was either using the hydrogen or ions. If we talk about the helium ion, helium actually contains 2 electrons. But I was using the He plus ion. He plus means what? Helium has lost 1 electron, so now helium is left with a single electron. That's why we can use the results derived by the Bohr's. Similarly, if I talk about the lithium ion, I was writing lithium as a Li2+, which means that now Li2+ has got the single electron. Now it will behave like a hydrogen atom. So the results drawn by the Bohr's model, that was for the hydrogen, now could be applicable to what? Lithium ion as well. So the first drawback was, it was applicable to hydrogen like species, means only, that is species having single electron only. Single electron only. So this is the First major drawback of the Bohr's model that it was applicable to those species which would carry only a single electron. If species carries more than one electron, then we cannot apply the Bohr's atomic model. This was the first major drawback. And after that, the second drawback was it could not explain the splitting of spectral lines in the presence of electric field and the magnetic field. This is the second drawback. It could not explain splitting. It could not explain splitting of spectral lines in the presence of electric field. This effect is known as Stark effect. And in the presence of magnetic field, which is Zeeman effect. Again, the drawback. So guys, these are first two drawbacks. We will discuss about much more drawbacks about the Bohr's atomic model. First of all, you have to note it down that first drawback was it was applicable to hydrogen-like species only, and the second was splitting of spectral lines in the presence of electric and the magnetic field, which is known as the Stark effect and the Zeeman effect. Note it down quickly. Then we will move on to next drawbacks. Note it down. Guys, have you copied it? Guys, have you copied it? Centers, Shillong, Sisipur, Senapati. Done? Okay. That's cool. So guys, let's move on to next drawback. The next drawback was it could not explain the formation of chemical bond. This is again a drawback. This theory doesn't talk about the formation of a chemical bond, how chemical bond is formed, and how molecules are stable. Next, it does not take account of de Broglie hypothesis and Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Uncertainty principle. Guys, there are two new terms. Here it is a de Broglie, and another one is the Heisenberg. That we haven't discussed yet. So I'll discuss these two theories after the completion of the Bohr's atomic model. We are doing the only last section of the Bohr's atomic model. Note it down. Note it down. So these are the major drawbacks of the Bohr's atomic model, due to which this model again got failure. So after consecutive many attempts, we came to know that Thomson model was not successful, even Rutherford model was not successful, even Bohr's model was not successful, and lastly there will be quantum mechanical model that was quite successful and which is still correct. So we will discuss about that later on. First of all, you have to note it down quickly. Done? Guys, have you done this? Okay. Okay guys, so that's all about your Bohr's atomic model. Over. Now, we have to discuss about the two new theories. Yeah. Broglie. That I have written over there. De Broglie. B-R-O-G-L-I-E. De Broglie. Now, the next theory is Heisenberg uncertainty principle. Heisenberg's uncertainty principle. See, Heisenberg, what did Heisenberg said? Heisenberg simply said that it is not possible to determine simultaneously exact position and momentum, or we can say velocity, of a moving electron in an atom. Heisenberg simply said that it is not possible to determine simultaneously exact position and momentum of a moving electron in an atom. So, actually, what happened? He said that, let's suppose this is an atom, and this is the path. We can say this is the orbit. Now, there is an electron which is moving here. Now, Obviously, we know that to see the objects, we need light. Actually, light makes them visible to us. So, if, for example, there is microscope on this position, here we have got the microscope. This is our microscope. Microscope. Okay. So actually this is the natural path of the light. Sorry, this is the natural path of the electron, that electron should move in this direction. In this direction. What happened? To watch this electron, we have given some light to it. So, which has energy E. What will happen over here? As the electron gains some energy, it will move faster. So what will happen? It will change its path and it might move in this direction. It might move in this direction. And this is the incident light that will reach to our eyes. This is your reflected light. Okay. Now, what happened? Actually, the path of electron should follow in this orbit. And as we have given energy to it, what happened? It has changed its path. So, it is not possible to determine the exact position and momentum of the moving electron. If we are able to see it, then we could not find its velocity. If we find its velocity, then we will not able to see it. This is what Heisenberg's principle said that. Now, he derived a relation in which, first of all, let us write down its statement. It says that it states that it is not possible to determine simultaneously exact position and momentum we can say velocity of a moving electron in an atom. This is the statement given by the Heisenberg. Now, he derived a relation that delta x dot delta p should be greater than or equal to h upon 4 pi. Now, p denotes the momentum, and we know that momentum can be written as mass into the velocity. So, I can further simplify this relation by writing like this: delta x dot delta m dot delta v should be greater than or equal to h upon 4 pi. So, this is our required relation that we should remember, and we have to solve questions based on this relation, where delta x is uncertainty in position, delta x is uncertainty in position delta P is uncertainty in momentum and delta V is uncertainty in velocity. Guys, note it down first. Then we will practice few questions on this. Have you cleared the Heisenberg uncertainty principle? What does it signify? It simply says it is not possible to determine exact position and momentum simultaneously of a moving electron. That's it. Either we can calculate velocity or momentum, or we can calculate its position. That's it. These are the terms used in the Heisenberg theory. Guys, note it down first and then tell me, is there any doubt regarding this theory? Anybody? Any doubt? Anybody wants to ask me anything in this theory? Guys, reply on the chat screen quickly. Do I need to repeat it, or is it clear to everyone? Have you noted down? Shillong, Senapati, Sisipur. Guys, what's going on? Where are you? 4 pi, dear. That is 4 pi. This is h upon 4 pi. Any doubt? Shillong, any doubt? Senapati, Sisipo. Okay. So guys, let's move on. What is delta V? Uncertainty in velocity. Okay? And m is mass of electron, which is equals to 9.1 into 10 to the power minus 31 kg. Okay? And remember guys, to solve the numericals, we need not to use the symbol of greater than. We have to simply use the symbol of equal to. That's it. Okay? So let us practice one question. See. The uncertainty in position of electron is 2.4 into 10 to the power minus 7 meter, then determine uncertainty in velocity involved. Uncertainty in velocity involved. Okay guys, do one thing. that in spite of writing only electron, m can also be mass of any object. Okay, you have to just remember it, or it can be mass of object. Might be they won't give you electron, they might give you some other object, so you will be given with the mass. So you can say mass of object if electron is not given over there. Okay, so you have to use that mass which is given to you in the questions. Okay, now let's take a look for this question. See, we are given with delta x, which is equals to 2.4 into 10 to the power minus 7 meters. Now, we have to calculate the delta V. What we have to do, just we have to put the value delta x dot m delta V should be equals to h upon 4 pi. Okay, as I have told you, we need not to use the symbol of greater than, we have to just use the symbol of equal to. Now, what we have to do? We have to just put these values and we have to solve it. See, the value of delta x is 2.4 into 10 to the power minus 7. Mass of electron is 9.1 into 10 to the power minus 31. And delta V we have to calculate, and is equals to what? H upon 4 pi. We know that the value of H is 6.626 into 10 to the power minus 34. And 4, the value of pi is 3.14. Now guys, solve it quickly and tell me the answer. Guys, solve it and tell me the answer. Solve it. Guys, solve it and tell me the answer. The student who will answer will give answer with their name. Shillong, Senapati, Sisipo. Guys, do it quickly. I'm waiting for your answer. Anybody has got the answer? Anybody has got the answer? Guys, are you solving or not? This question is for you. (1.4 10 to the power minus 4). Okay, we have got one answer. 7 8 4. Shillong, what's your answer, guys? Shillong, what are you doing, guys? Shillong, if you don't answer this question, I won't give you any break. I'm giving you 2 minutes to answer this question. Every center. If you won't answer this question, there will be no break in today's class. Meter per second. Okay. You have to pick one answer. Either 7 or 2. Shillong. And I have told you the student who write the answer on the screen should write the answer with their name. Senapati, who has got this answer? Dear, you have to write your name over there. Okay, quite closer. Answer would be delta V is equals to 2.4 into 10 to the power 2. This is the answer. Okay. So guys, this is the answer for the Hazenworks first question. So now let's take a break of 5 minutes. Make sure everybody will back in 5 minutes and we will continue after that. We will practice one more question and then we will move on to the next topic. See you after the break. Hi guys, back again. Are you there, guys? Quickly tell me, students, are you there or not? Every center will give a quick count over there. Okay, Shillong is there. What about other centers? Senapati is there. That's great. What about us other centers, guys? CC4, guys. So, guys, first of all, tell me, are you clear that we have discussed about the Heisenberg's uncertainty principle? Is there any confusion or any doubt regarding the concept that we have discussed till now? Any confusion, any query, any question? You can ask me right now. Because I'm giving you another question, and that question is quite good. Tell me. Any student, any doubt? Guys, you have to say yes or no over there. You have got doubt or not? Shillong. Okay, Senapati, CC4. Okay, so guys, let us practice one more question. First, you will attempt this and then I'll discuss it with you. Okay, write down this question. A golf ball has a mass of 40 gram and moving with a velocity of 90 meter per second. The speed can be measured. The speed can be measured within the accuracy of let's say 20%. Determine uncertainty in position. Guys, I'm giving you 5 minutes to attempt this question, and after that I'll discuss with you. Okay, and after that you have to solve it. You have to make calculations in this, and let's see who will got the right answer. You can note down this question and you can attempt this question. Remember, you have to use the standard units. For example, mass should be in the kgs. The velocity is already in the standard unit, which is a meter per second. Okay, now you can attempt this question. Do it. Have you attempted it, guys? Or still you need some more time for this question? Okay, take it. How many centers are there other than Shillong and Senapati? Guys, reply on the chat screen. The centers other than Shillong and Senapati, because they are constantly in with touch with me. Other centers are not. Okay, guys, let's attempt this question. You're taking little bit more time. See, we are given with mass which is 40 gram. First of all, convert this into kgs. So we have to divide it with 1000. So after dividing and solving, we will get 10 to the power minus 2 kgs. Now, we are given the velocity which is 90 meter per second. But there is a statement, it can be measured within the accuracy of 20%. Okay, means the uncertainty involved with the 90 meter per second is 20% actually. The statement signifies that the uncertainty involved with the 90 meter per second is 20% only. So we can have the value of delta V. How? 90% and it's 20%. Okay, so this is actually 20% of 90 will be the delta V. So you can solve it. After solving, you will get, how much you will get? 0, 18. Okay, this is the delta V meter per second. You have to calculate delta X. Simply put on the values and you will get your answer. See, this is 4 into 10 to the power minus 2. This is 18. This is delta X is equals to 6.626 into 10 to the power minus 34 upon 4 into 3.14. Guys, quickly solve this equation and tell me the answer. Have you understand the concept? Guys, have you understand the concept? Is there any doubt? Anybody? Guys, tell me the answer. Okay. Senapati, look at this. The question is saying golf ball has got the mass of 40 grams. So first of all, you have to convert the mass into kgs. So for that, what will I do? I'll divide this mass by 1000. So when you divide 40 by 1000, you will get 4 into 10 to the power minus 2 kgs. Now, you have got the velocity, which is 90 meter per second. Question is saying you can measure it within the accuracy range of 20%. So this 20% means it signifies the uncertainty involved with the velocity. So what will you do? Actually, the uncertain value will be 90 into 20 by 100. 20 by 100 means 20% of the 90. When you will solve it, you will get the value of 18. So you have got the velocity, which is the velocity uncertain. We can simply say the uncertain velocity. So now you have to just put these values, mass and the velocity, in the relation that we have discussed earlier, and you will get your answer. Guys, tell me the answer for this question. Senapati, have you cleared the concept? Shillong, have you got the answer? Shillong, what's your answer? Senapati, have you solved it? Have you solved it? Guys, what will be the answer for this question? You guys are looking quite lazy today. Done? Last 2 minutes, guys, for this question. These are quite simple calculations. Shillong, have you got the answer? Senapati? Okay, guys, you are taking too much of time. I think so. Answer should be this one. 7.3 into 10 to the power minus 35. Is it the answer or anything else? Guys, tell me. Is it the right answer or answer is anything else? Okay, that's cool. So guys, other students might note down the answer. I hope so this question is clear to everyone. Any doubt? Okay, so guys, let's move on. So that is all about your Heisenberg uncertainty principle. Now, next. Is your de Broglie. Okay, one more thing before de Broglie, you should write the significance of Heisenberg principle. Heisenberg's principle. First, as this concept denies that you cannot measure the exact position and momentum of the moving electron, it means the concept that we were discussing till now, the concept of orbit, was insignificant over there. For example, guys, look at this. If I say this is a circular path and here an object is moving in this path, or let's say suppose a person is moving in this path in this manner, I am saying this person is present here at a particular time and is moving with velocity 4 meter per second. So obviously this is a well-defined circular path. So if I know the initial position and initial velocity, and if I say it is moving with a constant velocity, so I can definitely measure its position after a certain interval of time, because here it is a well-defined path. But what Heisenberg said that it is not possible to determine the exact position and the momentum. Okay, so exact position and momentum can only be measured when there is well-defined circular paths. So the first significance was the concept we were discussing, the concept of orbit was proved wrong over here, that well-defined path and trajectories are not possible, because if there are well-defined paths, then obviously we should know about the position and the momentum, which is not possible, proved by the Heisenberg. Second, it was quite applicable to microscopic objects. Microscopic means which are very, very small. Okay? It was applicable to microscopic objects only. Are you getting the point? Microscopic means the objects which are very, very small. Okay? You can note down these two significances of the Heisenberg's theory. Note down these two significance, and after that let's move on to de Broglie concept. Note down. Done? Guys, have you done this? Guys, please tell me, is there anybody who has got any doubt till now in today's session? Any doubt, any question you want to ask me regarding the today's session that we have taught till now? Done? Shillong, Senapati? Okay. So guys, this is the significance, and yeah, remember guys, this is quite important for the state board examinations. Okay. So significance is quite important. You can mark it. Wait for the doubt or what? Is doubt coming? Yeah, tell me, what is the doubt? Tell me your doubt. 2 points. Yeah, ask me. Which 2 points? Oh, second point. It was applicable to microscopic objects. Okay. I'll explain it to you. See, we have just encountered with the relation delta x dot delta p is equals to h upon 4 pi. Okay. See, I can write instead of delta p, delta m dot delta v is equals to h upon 4 pi. Guys, look at this. If I solve it, delta x dot delta v should be equals to what? H upon 4 pi into m. Okay. See, h upon 4 pi is a constant. Now, let us discuss about the value of m. See, look at this. Delta x dot delta v is equals to h upon 4 pi into m. If mass is small, for example, if I talk about that mass is 9.1 in 10 to the power minus 31, which is very small, what will happen over here? If you solve this value, minus 31 will go at the numerator part and you will get it as a plus 31, h upon 4 pi into 9.1. Okay. Now, we know that 10 to the power 31 is a very big value and it is very easy to observe. Whereas, suppose I put the value of m as, let's suppose 40 gram, which is 4 in 10 to the power minus 2 kgs. Now, see, if I put this value over here, so h upon 4 pi into 4 into 10 to the power 2. Now, look at this value and look at this value. When you solve it, we know that there will also be some powers in the delta x and the delta v. Now, look at this. Which one is very easy to observe, 10 to the power 31 or 10 to the power 2? Tell me. Which one is easy to observe, 10 to the power 31 or 10 to the power 2? Obviously, we can say that 10 to the power 31 is quite easy to observe instead of 10 to the power 2. That's why we have said that it is applicable to microscopic objects, because after solving the equations, we will get the bigger values, and that bigger values quite easy to encounter and quite easy to deal. So we will get more accurate values for those objects where masses are less. If masses are high, then we will get relatively very smaller values, which is very difficult to deal with it. Okay? That's why we are saying that masses should be less, or we can say this is applicable to microscopic objects where masses are very small. Okay? So this is the concept of point number 2. Now tell me, is it clear to everyone? Shillong, who has got this doubt, is clear to you? Or do I need some other, do I need to take some other example to make it clear? Will it be fine? That's cool. So guys, this is the significance of Heisenberg's principle. That's over. Now, let us discuss about another one, which is the de Broglie theory. De Broglie's hypothesis. Okay. This is again a very big reason for the failure of the Bohr's model. The major reason for the failure of Bohr's model was Heisenberg principles and the de Broglie theory. Okay, de Broglie theory states that for every moving object, object says charged particle over here, because we are dealing with the electron. So this theory states that the moving charge particle has dual nature. Dual nature means what? It has a particle nature as well as it has wave nature. Okay, that was already proven in the physics, that any moving charge particle will have two types of nature, particle nature as well as the wave nature. Now, as we know that electron is also moving charge particle, therefore it should have both particle nature as well as wave nature. That couldn't explained by the Bohr's theory. That's why that got failed over there. Okay, so de Broglie simply said that any moving charge particle will have two types of nature, that is a particle nature as well as wave nature. Since electron is a moving charge particle, therefore it must have dual behavior, particle nature as well as wave nature. This is the de Broglie theory. Now, first of all, let us state this theory, and after that we will see its clarification, its concept, numerically, what happened actually over there. It says that any moving charge particle have dual behavior. Dual behavior, that is particle nature as well as wave nature. Since electron is a moving charge particle, therefore it must have both wave nature as well as particle nature. Now, the wave associated with matter is called we can say is material wave, and it is known as de Broglie wavelength. De Broglie wavelength. Okay, so guys, this is the theory of the de Broglie concept. Okay, de Broglie has simply said that any moving charge particle has dual behavior. So electron is also moving charge particle, therefore it should also carry the dual behavior. That's it, nothing else. Okay, so is it clear to everyone? Any doubt regarding this? Guys, Shillong, Senapati and the other centers, because they are not here. Guys, you have to prove your presence. Shillong, is it clear to you? Senapati, any doubt? Anybody wants to ask me anything? Any question, any query, any doubt, any point that you think you should ask me? Arrow point. Okay. Dear, that arrow point is simply that about that matter or the charge particle we were talking about. Obviously, there must have some wavelength, because that is a moving charge particle. Okay, so that wavelength is known as the de Broglie wavelength, because this concept was given by the de Broglie That's why that wavelength is called what? De Broglie wavelength, nothing else. The arrow point simply says that the particle about which we are talking about will definitely have certain wavelength, and that wavelength we are talking is known as the de Broglie wavelength. That's it, nothing else. That's what the arrow point signifies. Is it now clear, Senapati? Is it clear now? Okay, so guys, look at this. We know that E is equals to mc square, which signifies the particle nature, whereas E equal to hc by lambda is your wave nature. Okay, since both are the energy forms, see, this is energy which is equals to E equal to mc square, this is the energy which is equals to hc by lambda. So as both are equal, so we can equate these two. So we can say that mc square should be equals to what? hc upon lambda. 1c will be cancelled out. Now I can solve it for the lambda. So lambda would be equals to h upon mc. This is our required relation. Now this is our required relation that we have to remember. Now, as we know that mc is what? Momentum. So we can say that lambda should be equal to h upon p, where p is what? Momentum. So here we have got another formula for the lambda, that lambda is equals to what? H upon p. As we know that as we know that h is a constant, so I can also write it like this. See, lambda is equals to what? H upon p. So I can say that lambda should be inversely proportional to p, because h is a constant. If I remove this proportionality sign, then I will put a constant h over there. So now this is another important thing, that lambda is equals to 1 by p. P is the momentum. We have to remember these terms, that one second, see, m is mass of object, p is the momentum of the object, c is the velocity. Guys, remember one thing, c, by the c we generally represent the speed of the light. Okay, here the c will be the velocity of object. Until unless is mentioned, you will use the speed of the light. If this says the speed of object is this one, then you have to use that speed. Okay, you won't use the speed of the light in that case. Okay, you can note it down quickly. Note it down. After that, I'll drive one more important relation for you. Guys, remember, this is quite important relation, and there are many questions asked in your examinations regarding these relations. Okay, note down. Done? Guys, have you done with it? Okay, that's cool. So guys, look at this. We know that kinetic energy is equals to half mv square. Okay, you have to do one thing. You have to multiply m in both sides. Okay, so what will we get after multiplying it and place 2 over there? We'll get 2 into m into kinetic energy should be equals to m square into v square. If I solve this square, I'll get mass into velocity is equals to under the root of 2 into m into kinetic energy. Okay, see this. Okay, now what we have to do? Look at this. We have just seen lambda is h upon mc, and I have told you c is the speed of the object. So I can use lambda is h upon mv in spite of mc, and I can put this value of mv over there, and after putting this value I'll get a new relation that lambda is h upon under the root 2 into m into kinetic energy. This is the new relation. Guys, are you clear with this relation? You have to remember this one as well. Any doubt? Note it down. Guys, copy it and tell me, is there any doubt regarding this relationship? Anybody wants to ask me anything? Guys, done? Dear, I have just told you that kinetic energy is equals to half mv square. I told you to multiply mass in both the directions. See, I have multiplied mass here. Sorry, one second. Mass here, and here I have also multiplied with the mass. We know that according to mathematics, if in the LHS side and the RHS side, if I make the same operation, there will be net no change. So I have told you to put this 2 here. What will I get? 2 into m into kinetic energy, and is equals to what? M into v square. Now I have solved this square root, and I'll get mv is equals to under the root of 2 into m into kinetic energy. We have just learned this relation that lambda is equals to h upon mv. So what do we have to do? I have just put this value of mv. See, this value of mv here. So after putting this value, I'll get this new relationship. See. Tell me. Now, Senapati, is it clear to you? Senapati, now is it clear to you? Or still you have got some doubt? Okay, is it clear to you? That's fine. So guys, this is the de Broglie concept. Remember, numericals are again very much important in this, based on this concept that we have to discuss. Okay, so let's write down a question. See, electron is moving with a speed of 4 into 10 to the power 10 meter per second. Determine wavelength associated with it. Do it. You can do this question, guys. Attempt this question quickly. I think quite easy question. You can do it very easily. You have to just use the relation that we have just derived, that lambda should be equals to h upon mv. You have to just put these values, 6.626 to 10 to the power minus 34 upon mass of electron is 9.1 into 10 to the power minus 31, and velocity we have given is 4 into 10 to the power 10. You have to solve this one and you will get your answer. Do it. So guys, I need answer for this one. Do it. Done? Guys, what's your answer? Quickly. Okay, we have got one answer, 1.8 10 to the power minus 14. Okay. 31, 3. Yeah, very good. The answer would be, who's got this answer from Shillong? What's your name? Who has got this answer from Shillong Center? So guys, this is the answer. Okay, so that's it for today's session. Congratulations who has got this answer. Very good. This is the right answer. So that's it for today's session, guys. Take care. Bye-bye. See you next time.